Hi everyone, thank you very much for joining me at this talk to Detekt 2.0 and beyond. And please let me tell you how excited I am to be here. First, full room, this is awesome. The last time Detekt was represented at KotlinConf was in 2018 from one of our former maintainer, Maven. And yeah, it's such a pleasure for us to have a stage here. Let me just ask you, how many of you here are using Detekt in your project? Awesome. So yeah, today we're going to learn more about this tool. And but before we deep dive, a couple of notes. First, we do have another maintainer here, Chao, in the first row. He's like another maintainer of this project, so please reach out to us afterwards if you have questions or doubts. And also mandatory slide about myself. My name is Nicola Corti. I'm a Kotlin GD. You can find me online everywhere as Cortinico. And also, well, let me do this. I also run a podcast. It's called The Developers Bakery. You can find it online on thebakery.dev. I spotlight open source projects. A lot of them are Kotlin-based. So make sure you subscribe, hit the bell icon, and whatever. But since I have so much to cover, let's deep dive into Detekt. So as some of you raised your hand before, but not all of you. So I will actually reiterate a bit on what Detekt is, what this tool is about, how can you use it. Then, yeah, the second part of the talk will be all about the latest release of Detekt. That it's going to be the 1.23. And then I'm going to spend the last part of the talk talking about the future, so what's coming next. So let's get started. So what is Detekt? Detekt is basically a standalone static analyzer for Kotlin. It just allows you to inspect your code, enforce best practices, and so on. You can find it online at github.com/detekt/detekt. And we do have a lot of rules, more than 200. And those are all community contributed. People come over. We took inspiration from effective Kotlin. We ask experts or people that are maintaining big projects which pattern they want to enforce. And over the time, we created, yeah, a lot of rules. And having those 200 rules all together is quite hard to maintain, also hard to discover. That's why we organize them into rule sets. We have several of them, and those are collection of rules that sort of help you in specific areas of code maintenance. For example, improving performance or improving the style of your code. And how do you configure Detekt? Detekt offers a configuration file, which is basically a YAML file, where you can declare which rule set you want to activate or we want to disable. And for each rule set, you will have a collection of rules. In this case, let's pick one. This is probably one of the most popular one. I'm sure users of Detekt saw it, and it's called magic number. So it detects magic number in your code. You can activate it with active true, and then in the config file, you can specify other configuration, which folders should be excluded, which number should be included or ignored, and so on, and a bunch of stuff. So our tool is quite flexible. We do have our config file grew quite a lot, and you can configure your rules as you wish. But to get a little bit more practical, let's see what magic number is actually doing. So let's say that you have some code, function main, you want to print something on the screen, and you want to print it only if the random number is more than 42. And well, this is not great, because you are having just a random number over there. Detekt will run and will tell you hey, this expression contains a magic number. Consider defining it to a well-named constant. You should have a top-level constant called whatever answer, and put it there. Now let's take a look at another rule, another example. Unnecessary not null operator. So this will check if there are not null operator which are unnecessary. For example, let's say that I have a variable 0, which is 0, and then I have another variable called answer, and I do 0 plus 42. Again, if I change this code and I add a double bang here, this doesn't really make sense. Why am I doing a not null operator on 0? It's an int. So Detekt here will warn you and tell you 0 double bang contains an unnecessary non-null operator. Why I am presenting you those two rules and those code snippets which are quite stupid? It's because those two rules, albeit simple, they are so different in the way how Detekt operates. So specifically, the rule on the left is doing syntactic analysis. So it's just checking the tokens in the code and is finding they're using like a number in a comparison and is telling like, hey, this can be a constant. While the rule on the right is a little bit more advanced, because if instead of having val0 equals 0, I do something like that. I invoke a function, get a number. And let's say that this function comes from an SDK or a library that you don't control. At this point, well, Detekt doesn't really know what's the type here. It can be an integer, it can be like a nullable integer, and yeah, we need to know the type of that function, like what's the return type there. And this allows me to introduce one concept that is key to Detekt and to Detekt 2.0 and so on, which is type resolution. The rule on the left is a rule that runs with type resolution, needs to have semantic information, needs to have more information from the compiler to know what's the return type to get number, to be able to run those sort of more advanced analysis. So how do you use Detekt in practice? Our preferred entry point is the Detekt Gradle plugin, which you can enable like that. So in your plugins block, you just apply our plugin, and you can use the Detekt block to configure it. This will add some tasks to your Gradle task graph, which are specifically those three. Detekt, which just runs Detekt, as you can imagine. Detekt baseline, which creates a baseline file, which is sort of a dump of all of your findings. This is really useful if you're adding Detekt on a big code base. And that Detekt generate config, which creates an initial config file that you can iterate on. But we are a little bit more smarter in the sense that if we find that you also apply the JVM plugin, the Kotlin JVM plugin, or the Kotlin Android plugin, we sort of create more tasks for you. And in this case, other than the Detekt baseline, and generate config, we also create those baseline main and baseline test, and more importantly, Detekt main and Detekt test. Here's where things get confusing for some, because people say, why do I have Detekt and Detekt main and Detekt test? Well, the catch here is that those tasks which are created per source sets, those have type resolution enabled, because at the source set level, we can know which dependencies you're bringing in. Let's say that get a number function you are bringing in as a different dependency between your tests and your main source set. So the type of that function could be different. So Detekt should run inspection with the dependencies you bring on. That's why we have those more advanced tasks for you. So effectively, the TLDR is that if you invoke Detekt main, you're actually running a more advanced inspection, and we use your production dependencies to run the inspection. Similarly, if you use Kotlin multi-platform, we added support inside Detekt. So again, if you have the Kotlin multi-platform plugin applied and you have a set of targets, we generate more tasks. And in this case, it kinda explodes because we have baseline and inspection for all the tasks, for all the source sets basically. But yeah, effectively, this is what allows us to have those type information for all the targets that you might want to run inspection on. And it's not just that. We do have a lot of other integrations, which I would love to cover, but I don't have much time, and I want to spend time also on 2.0. But yeah, we have plugins for Bazel, for Maven, for Danger.js to add things in your pull request. You can integrate with GitHub. You can use Serif, which is a format which is understandable by GitHub, and Detekt will comment on your pull request if there are inspections found all over the places. You can brew install Detekt and have a CLI that can inspect file locally. And we also have an IntelliJ plugin. So some of them are developed by us, maintainers. Others are community contributed. But the point here is that this is just a huge ecosystem. We started as, this thing started as a side project. And it's so awesome to see the community picking that up and building integration on top of us. And we are so excited to see those extension. And talking about extension, I think the power of Detekt is actually when you write your custom rules. And how do you do that? Here we got you covered because recently we created our custom rule template. It's a repository, which is actually a GitHub template that you can use to create a new rule immediately, and be ready out of the box. You effectively need to create 3 files, which are the rule, so the logic of the inspection, the rule set provider, which is the collection of all the rules you want to expose, and we'll create a new rule set like the one I showed you before. And then we use the service locator pattern to specify which rule set provider needs to be loaded. Once you have those three, you can just, like, if you use Jetpack, you basically have your rules already published on a Maven repo, and everyone can depend on that. And this is so powerful that it inspired us to create the Detekt marketplace. So if you go on our website, on the marketplace tab on top, you can find all the third-party rules that people wrote, and they added on our website so they can find them and discover them. For example, one popular one was the compose rule set by Twitter. And we saw that a lot of people actually wanted to pick up on using Detekt with compose. But at the same time, we don't want to sort of bend Detekt to serve only a certain framework, because you might use Detekt with Spring or with any other framework you want. So Detekt is like framework agnostic in a sense. But we understood that people wanted to use compose so much. That's why we created a dedicated page on our website that explains you how you can configure Detekt to work well with compose. Like, for example, we see a lot of top-level functions which have a different naming and so on. So yeah, either you can use one of those third-party rule or use our configuration to sort of have inspection which are more specific to your dedicated use case. And this brings me to our website. You can find all the information on Detekt on detekt.dev. We recently redesigned that, and the cool part here is that all of those inspections have like those IDs, like magic number or unnecessary not null operator. And when they appear on console or wherever you want to integrate your inspection in your CI or pull request, the user can just search for the ID in our search bar, and you will jump straight into the definition of that rule. And for every rule, we have like examples on what is the compliant code and not compliant code, and also we specify if that rule requires type resolution. This is one of the most asked questions. Like, people come to us and they say like, hey, this rule doesn't work. And the problem is like, your rule needs type resolution and you're running Detekt non-main, so you're not running that rule at all. And we hope we can like explain this concept better. This also, this new redesign of the website allows us also to have version docs. This is another source of confusion for users because we evolve our rules, we add new configuration, and people say like, I go on the website, I see this config field, but it doesn't work on my project because they're using older version of Detekt. So now you can find for every rule which config is available on any given version. And talking about versions, so yeah, like now I sort of gave you this brief introduction on yeah, what is Detekt, but now I want to talk a little bit about where we came from. Like it was a long journey. Like we stick to being stable 1 dot for so long, and last week we released 1.23.0 RC1. So this is the first release candidate of 1.23. And it's sort of like the first step towards what will be 2.0. And to fully understand 2.0, I want to spend some time talking about 1.23 and what is basically going to be available in a matter of weeks at this point, because we do RC1, RC2, maybe RC3, and then stable is out and is usable by everyone. So let's look what 23 will bring. Well, the biggest change, like the most important one, is sort of like a shift in our paradigm. So nowadays, if you use Detekt and you invoke Gradle build, you will be doing a lot of stuff. Well, you will be compiling your code, obviously, and you will be also running the Detekt task, which is plugged inside the check task, which is called by build, and so on. So you will be running both. And as I said before, Detekt, the plain one, doesn't use type resolution. The problem is that if you want to run Detekt main at this point, well, as I said before, we need to have those type information. And the way how we get those type information is because we use the Kotlin compiler embeddable, and we effectively run another compilation. And well, as you can imagine, this is terrible for performance. Compiling your code twice is not great. And it gets even worse when compilation flags gets out of sync. Like if things, when your code is compiled, are not the same when Detekt is looking at it, For example, if you're using view binding on Android, or if there is like code generation involved. If on Detekt we are not able to collect those compiler flags properly, the view that Detekt has on your code is not the same that the compiler has. And well, yeah, it gets complicated. Like getting the correct class path every time is also quite hard. Well, there is a solution to this, and the solution is compiler plugins. So Detekt 1.23 will ship with the experimental Detekt compiler plugin for K1. It means that we will not be generating Detekt tasks anymore, but we will plug inside the compiled Kotlin tasks. And yeah, we will be like closer to the compiler, and we will have like a better view of the semantic information that the compiler knows. So no more double compilation, everything will be faster, type resolution are close to the production code, which is great, and no more custom tasks for every source set. Like on multi-platform, it was like really getting out of hand. And yeah, this is quite awesome, but it's experimental. Like, we are looking for feedback. There are some drawbacks from using a compiler plugin rather than using like a plain Gradle plugin. So we would love to hear from you. And practically, this will work in this way. So now you have like the plugins block where you declare this Gradle plugin. You will just use another Gradle plugin, which we also publish. And practically, when you, for example, call assemble or build, inside the compiled Kotlin task, you will see stuff like magic number. This expression contains a magic number. So we are sort of part of the compiler flow, in a sense, which is awesome, especially because getting back to that multi-platform list of tasks I showed you before, a thing that I haven't mentioned is how we are able to do type resolution with the plain Gradle plugin for JVM and Android targets only. That means that those more advanced rules don't work for iOS and native targets and JS targets and so on. So those tasks effectively, like Detekt iOS x64 main, is not running with type resolution with the Gradle plugin. But with the compiler plugin, we can actually solve those problems, which is great. And also, having those tasks, like, it's super confusing for user to know that the Detekt JVM main works with type resolution and the iOS does not. So yeah, hopefully the compiler plugin will solve this. The idea is to keep on supporting both the compiler plugin and the Gradle plugin for the time being. 1.23 brings also some nice stuff. For example, new rules. We have 8 new rules lined up for 1.23. I also want to mention some that got shipped in 1.22. So this is like a total of 24 new rules. And the thing is, like, it's great in the sense because, as I was saying before, those rules are community contributed. Like, literally, we have conversation in the Detekt issue tracker about what it means to write elegant Kotlin code. Like, people come there and tell them, like, hey, I noticed this pattern in my code base. Would that be an idea for a new rule? And then we have like conversation on the issue tracker. People say like, yeah, maybe, yeah. Or, I don't know, Kotlin 1.8 is introducing this new feature. How about we write a rule for that? So it's so great to see the community engaged in creating those rules, and we're so proud to ship more in this coming version. I also want to call out that we started a partnership with Gradle Enterprise. So now you can find our public Gradle Enterprise instance at ge.detekt.dev. And this is sort of helping also populate remote build caches for people that contribute to Detekt. And folks at Gradle are awesome. They also helped us sort of clean up our Gradle build, which is actually quite complicated. And we are spotlighted on the Gradle Enterprise customer. And we just want to say thank to them for supporting us as an open source project and giving us resources free of charge. 1.3 will also be like the classical tool alignment. So again, a lot of people have been asking for a new version because they want to work with Kotlin 1.8.20 and so on. So basically, we will be like, again, bumping all the dependencies to the latest one, so you can use the latest version with Detekt with the latest version of Kotlin. Reports have been revamped a bit. The HTML one is a bit nicer, so yeah, we did a little bit of CSS. And also we added support for Markdown reports, which you can plug it inside your GitHub action flow. GitHub added support for adding Markdown outputs to your build. So yeah, we sort of integrate with that as well. And finally, we also added 2 new rule sets, which are actually external, basically they integrate in a similar way as those external rule sets I talked about before, but we maintain them. And the first one is the libraries rule set. The libraries rule set is a collection of rules that are specifically designed for library authors. For example, we noticed that when you write code that is library, like APIs and so on, you need explicit API mode, and you need to think of your API in a different way. So we collected all the rules over there. And we added another rule set called rule authors, which is a collection of rules for people that are writing Detekt rules, which it turns out there are a couple. First, this is useful for us because people send us rules and they keep on doing the same mistakes over and over. And so we thought, okay, how about I write a Detekt rule for you? So I tell you, if you're doing something wrong, we violate types resolution requirements and so on, which is just great. But if you plan on sort of writing rules, those are also helpful because they will catch a couple of common mistakes. And now, time to talk about 2.0. And here I want to call out how, 2.0 was in our minds for so long. I think at least for 2 or 3 years, 2020 for sure. And this is what happened is what I call conference-driven development. You know it, right? So basically, we said okay, someone should send a talk at Kotlin Conf because it's happening in person. So I was okay, let's try to talk about Detekt 2.0. And then the talk got accepted, and we were okay, 2.0 needs to happen at some point. So we sit down and we say okay, how about we collect all of our ideas and we decide how 2.0 will look like and what we want to have and what we don't want to have. So what I'm presenting today is the list of features which are lined up to be released in 2.0. So the first thing is I want to explain how our code setup will look like. We will be releasing 1.23 from main in the coming weeks. And 1.23 is going to be the latest release that we will be releasing from main that has the 1.x versioning. The following one will be 2.x. And there will most likely be alphas and betas, just because it's contains way more breaking changes. So we will be it would take a little bit longer to release that version. In the meanwhile, JetBrains will probably release 1.9, and you will all come to our issue tracker shouting to have a new version of Detekt that works with 1.9. So maybe 2.0 will not be ready by then, so that's why we will be maintaining a branch that will keep on releasing 1.x. So there might be a 1.24 at some point. And so what to expect is 2.x will contain new rules and new features. So if you want to add a new rule to Detekt, either you do it now or tomorrow, and we include it in 1.23, or it will end up in 2.0, and you will have to wait a little bit of time. And also a lot of breaking changes, which we have lined up and we want to do, and we need to break some stuff at some point. 1.x instead will keep on having tool version bumps, and then also we will backport some of the bugs. And bugs for Detekt means false positives and false negatives. We have tons of them. So we might decide to just backport some, and then by the time we release a new version, 1.24, that contains the alignment with Kotlin, Gradle, AGP, and so on, we might just include some of those false positives, false negative fixes. And so what are those breaking changes about? Well, the first one is a little bit obvious. And if you look at the template that I showed you before, and also if you look at the Gradle configuration, you will notice that we have a little bit of historical background here that we're carrying around. I want to say thank you to Arthur Bosch for starting this. If you don't know, this was his master thesis. And we took it from there, and again, we created a mini ecosystem around it, which is awesome. But we are not on GitLab anymore, and we do have a domain. So how about we sort of clean everything up and use dev.detekt, which will make things easier to understand. Also, compiler plugins and Gradle plugins have different IDs, which are super confusing for user. So we'll reconcile everything under dev.detekt, and we'll explain to people what are the new Maven coordinates, what are the new packages that you need to migrate to, and so on. Talking about breaking changes also, we collected a lot of deprecated properties. Like, what happens is, like, we add a property to a rule, and then at some point we realize, this property doesn't really work well. Maybe we need to split it in two. But what happens with the old one? We deprecate it. And we collect all of them in our deprecation file, which is used to inspect your config file and tell you, like, the rule inside complexity, which is called long parameter list, and the parameter threshold is deprecated. You should use function threshold instead, and constructor threshold. Those things will go, and those old config will also go. So yeah, your config file will not work at some point anymore. We will not have those warnings. So if you're up to date with Detekt versions, you're probably fine. But if you're jumping from a really old version to 2.0, maybe the best thing is just to recreate the config file and recustomize it as you see fit. On top of this, we have some functions named that don't really make sense. For example, function max length. You might think it like the function body is too long. Actually not. That is checking the name of the function if it's too long. So that should probably be renamed to function name max length and so on. So those changes to rule names are like breaking changes again, because the config file change and so on. So we will be shipping all of them in 2.0. The other thing that is quite controversial is the whole detect main thing. People don't understand it, like, really, and the naming is terrible. So we need to find a better way. Like, on one end, we have the compiler plugin. Some people might use it, and maybe that will become the most popular adopted way. But we still want to support Gradle users, like people that are using the plain Gradle plugin. So here, we are a bit unsure on how to evolve it, and we identified two solutions. The first one is to have two tasks, one called Detekt Full and one called Detekt Light. And the name here is more like, has more meaning. Like, it really clarifies that you're doing the full inspection versus a lighter one, which works better for like pre-commit hooks or so. The other option is to allow those tasks to configure if they want to use type resolution or not. So you will not have a detect main and a detect task anymore, but you will have like a single task and then or like a collection of tasks, and on the task you can say like, yes, I want type resolution or not. The interesting thing here is that like in 2.0, type resolution will be on by default. Today, this is not the case. When you enable the Gradle plugin, we register detect task as a dependency of check, which is a dependency of build, which means that by default, you will be running without type resolution. 2.0 will change this. So this is like a behavioral change. And again, this allows us to have more powerful inspection, and also allows to fix one issue that is really close to my heart, which is rules with mixed behavior. We do have some rules inside Detekt that behaves differently based on whether you have type resolution enabled or not, which is terrible from the user perspective, and we will be moving all those rules to require type resolution only. So if you are using Detekt without type resolution, those rules will stop working in 2.0. Some changes are lined up also for our Gradle API. If you've been doing Gradle plugin development, which is a pleasurable experience, you probably know about something like that. Like we are carrying around this terrible stuff, which is like our tasks have properties and non-properties inputs. So for example, we have JVM target, which is what we expose, and then we have JVM target prop, which is the property. And the problem here is that because of Kotlin DSL, this is a breaking change. Like the way how you do JVM target will change. You will have to do .set and so on. We never wanted to publish this, to sort of clean this up, because we are afraid of that being a breaking change. We will actually clean that up. The good news is that maybe you've been following, there's been a keep around on overloading the assign operator, which has been killed. And actually, Gradle picked this up. And the good news is that Gradle 8.1 got released like yesterday, which contains support for Kotlin DSL assignment thing. So this will be like a non-breaking change. But our Gradle API internally will be modified, and we will be using all the idiomatic Gradle way of doing things, and we'll be cleaning up a lot of stuff. Then another change that we have lined up, and this is sort of like, the embarrassing thing, like, I don't know. We need to talk about this. So we do have Kotlin wrapping, and sort of, it works in this way. So we do have a rule set called formatting. And the formatting rule set is effectively the Kotlin wrapper. So we have a collection of rules there that they're not having a logic per se, but they're like deferring all the inspections to Kotlin. This is a convenient way that allows you to just use Detekt and run Kotlin internally, which also means that we have like a one-on-one connection between a Detekt version and a Kotlin version. So again, it's a custom rule set. You need to plug it. And yeah, there are problems because if you look at those rules, like I'm picking 2, no wildcard imports and no unused imports from the formatting rule set. We do have other rules on Detekt, like in the style rule set. For example, we have a rule which is from Detekt. It's called wildcard import, which has even a configuration exclude imports. And then we have the Kotlin rule, which is called no wildcard imports. With the S, and the other is without the S, oh my God. And then we have like a rule called unused imports and no unused imports from Kotlin. Yeah, so should we remove it? Maybe yes. I mean, the point is no one from the current maintainer were there when these things got added. And for us, it's sort of like kind of a pain to maintain in the long run, but we are committed to supporting users. So if you folks are using it, that's maybe something that we can keep on doing, but if there is value. So the thing is, we opened a discussion today, and it's called, should we remove Detekt formatting? And it's actually a poll. So go there, leave your feedback, tell us if you use this. 123 will ship with Detekt formatting, for sure. 2.0 might not, based on what's the feedback here. So we're really keen on hearing, like, do you need this or not? Because we are like a group of volunteers. At the end of the day, our resources are limited. If we keep on maintaining too much, things will get slower. So let's focus on what is important for us all. The other thing is, as I was talking about Kotlin, Detekt has this thing called autocorrect. So basically with Detekt, you can actually write rules that modifies the code, which sounds like, especially with all the AI thing going on, it sounds like super powerful. But Detekt maintainers' stance on this is like, we don't want like first-party rules inside Detekt that modifies your code. And Detekt 2.0 will keep on this same vision. We allow you to write Detekt rules that edit your code, and you can do whatever you want. Kotlin wrapper actually does that, because that's how we allow Kotlin to modify the code. But the problem is like moving in a compiler plugin Word. No, editing the code while the compiler is running is like, it can lead to really bad state. Like you can edit the code, and then if the rule has a bug, you bring the code to a state that doesn't compile. Not great. So we will keep on having this API, but we will not be allowing rules that have autocomplete enabled inside Detekt. We're going to review also a little bit the concept of severity. So inside Detekt, we have this class called severity, which is part of the public API, and has this note on top that means this will be replaced by severity level in a future version of Detekt. So now the future is coming, so this is going. But what does this mean? Like, when you write a rule, you can specify what's the severity. And one of the class of the severity is warning. And the problem is that, like, this is super confusing, because it's not the kind of warning you will think about. Like, it's just like, it's basically a tag. Like, it's a way to say, like, this inspection is like a warning, but your build will fail regardless. So Detekt doesn't have a way out of the box to report non-fuddles. And we'll be looking into this. We're going to clean up this class, which has like too many things. And yeah, we will be bringing a way to express rules that should be reported, but should not be accounted for build failures or like negative status that goes out of Detekt. And another thing we'll be looking on is also suppression. So on Detekt, you can suppress locally things using @suppress and the ID of the rule. You can suppress on any like nesting block or at the file level. But what happens if you actually fix this problem, like by exporting the constant, like this is valid code, it's not a magic number violation anymore? Well, the problem is that you still have that file suppressed there, and this is not relevant, and it's also harmful. So yeah, but I mean, we are a static analyzer, so we can technically inspect all the @suppress annotation and see if they're actually suppressing anything. So we'll be looking into adding support for finding invalid suppress within Detekt. The problem here is that you might suppress things also for other tools because everyone is looking at these @suppress annotations. So yeah, we're still inspecting and discussing on how this will be implemented. But yeah, this will come in some form. And then another thing we are looking into is this. Let's look at those classes, those rules, like class naming, and class naming as a pattern, as this config class pattern that, as you might imagine, it just checks the pattern of your class name, and then you have also function name, like these other regex. Okay, so let's say that now you want to enforce that every class in your tests should be called blah 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 test or blah 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 spec. This is not possible today with Detekt, or it's not easily possible. There are ways to do that. The easiest way how we can do this today is to add two configuration. We could tell you this is the class pattern and this is the test class pattern. This is really not great. The problem here is that you want to instantiate your rule twice, and you want them to be instantiated on different parts of the code bases with different configuration. And we call this multiple config instantiation. This is quite complicated because of our config file is structured in the sense that the rules are primary keys, you can't have another class naming there. So we'll be adding a more advanced way somehow to do this. And this is still more up for debate. Yeah, it's still in design in a sense. And then last thing that we will bring on is also a lot of users have been asking for merging things, like merging reports and merging baselines. So the problem with Detekt, and I think also with other sort of similar tools, is that we work as a Gradle plugin, and Gradle plugin works well where they're project isolated, and they have a view only on a given project, like a module, which is great. But then people want just a final report for the whole project, and people want a single baseline for everything, which is not really how Gradle want things to do, to work, but I can understand the use case. So for merging reports, we already have support. Those are on the website, but it's more like a custom thing that we tell you how to do it. It's not really plugged inside the Gradle plugin. You need to create a custom task. Not great. So those will be sort of better integrated. And for merging baseline, that's also something that we're looking into, and they will probably also come. But again, maybe you noticed that as I was talking about 2.x, I went from things where that we're sure we're gonna do, and then the more I was going at is more things that are up for debate. So yeah, things are in the making and they will be coming in some form. I can't tell you today how specifically the baseline and report merging will look like, but yeah, they're coming in some form. And now, as I have some minutes left, I actually want to talk about sort of the elephant in the room. Because, well, there's 2.x, but actually I can sneak peek about 3.x. And the thing is, I'm sure everyone is asking, hey, how about Kotlin 2.0? What does this mean? And yeah, effectively, we envision Detekt 3.0 being released for Kotlin 2.0. Yeah, so the thing here is, well, Detekt works with the PSI and with the binding context. And those things are going away with the new compiler. We don't have those information anymore. Technically, if you saw the keynote, the whole release of Kotlin 2.0 will be they're trying to make it as close as possible to 1.9, which means that by the time 2.0 is out, maybe also Detekt 2.0 will be out, and that will use the old compiler, and that will just work. We should be able to run inspection using the old compiler. Maybe the compiler plugin will not work at that point. We will need a K2 compiler plugin. But at some point, JetBrains will start adding new features and collection literals And that code, Detekt will not understand it anymore unless we migrate everything. The cool part is that we do have like a strong foundation of tests. Like we have thousands of tests. So the way how we envision that is like asking the community support. So that's the list of all the rules we have, and is quite long, 200 plus. But yeah, it shouldn't be that hard, given the amount of tests we have, to just like pick one rule, migrate it to use the newer API. I'm sure we're gonna make like examples on how to migrate some, and then people can just like help us migrate 1 or 2 rules if they want. And please do so. Like we will share more details on how to do that. And with this, like I really want to mention how awesome this community is. Detekt is us. Like there is no company behind this. Like we are getting like some sponsorship, but it's really like little. And the people are putting their time and passion in building something that works for the whole community. We're not JetBrains, like, you know, obviously they have like inspection inside IntelliJ and the work are awesome, okay. But like, I personally believe in this project. For me, the community around it is just awesome. And it was amazing to see like people onboarding on it. It's just great. So think about if you want to sort of help us. Specifically, we sort of created this call to action discussion to join what's going on with Detekt 2.0. So practically, a lot of the things I said today are just actionable. And like there will be like a list of things to do that you can just pick and start contributing if you like this, this project and this idea. And it's a great way to sort of help the Kotlin community as a whole. This is more like kinda like it's a generic call to action because I didn't want it to spoil the content of this talk before. But in the next days, we will be publishing all the information I shared today, plus other stuff that could not make it inside the talk today, on how people can effectively remove those deprecations or help us rename things or help us change package and so on. So please consider donating back to the open source community. And talking about donation, we do have an open collective that you can reach through the GitHub donation button. So if your company is using Detekt, please tell them, like, hey, how about we give back to the open source community somehow? Or if you just want to donate spontaneously to our project, we'll be more than happy. And since I'm at KotlinConf, I actually want to clarify one thing. Yeah, is Detekt lowercase? I love uppercase. I had to go through this whole presentation because all the Detekt are uppercase. But yeah, it's Detekt lowercase. We do have stickers also to give away, some of them. And I hope you enjoyed. I hope you enjoyed our the talk. I hope you enjoyed our tool. And thank you very much. And don't forget to vote. I do have time for a couple of questions, if there are any.
Thank you for the talk, first of all. And as you said, people don't understand main versus non-main, and I'm one of those people. So basically, my question is, if right now we are not using the main task,
yeah,
are we missing some rules?
Yeah, you are.
Oh.
Like if you go in the Detekt website, all the rules that are marked as requires type resolution, you're not running them at all.
And if we use the main, we will be compiling twice.
Yes, so if you run Detekt main, you will see that that task will take longer than just Detekt. And you will be running more rules. You will be running like a more advanced inspection. The thing to know is that we have this partnership with Gradle, and they helped us refine a lot of our API and be like fully compatible with configuration cache and so on. So you will have to pay that cost at some point. But yeah, we are quite optimized with the Gradle integration.
Okay, and last one, if I would like to avoid the double compilation, I should give a try to the compiler plugin.
Yes.
Okay.
So the compiler plugin was like in its own separate repo for a while. Now we moved it inside Detekt. That means that it will be released alongside Detekt from now on. 1.23 is going to be the first version where the plugin will be publicly available, but we consider that still experimental in the sense that the Gradle plugin, the plain Gradle plugin has been developed for like years now, and we know that's stable. The compiler plugin instead is like sort of new still. Like we know someone has been using it, it's working well for them, but there might be rough edges, might be even features that are not fully supported. So yeah, at this point, we want to ask like more feedback from the community if it's working for you or not.
All right, great. Thank you.
I think I'm also at time. So yeah. Thank you very much.